Hi again. So in the previous video, I showed you how to declare the panel data structure. After loading the data, you have to declare what is the panel ID variable and what is the time ID variable, time variable. And I showed you string variable is not accepted, so the identification must be number. And I improvised something, but it did not work. Sorry about that. That's the problem of improvisation. Anyhow, now now because we declared the regression, you may use the fixed effects model. Fixed effects model. I will double click, double click, double click. So the fixed not doing this. I will show you how to do it here. So I will use this this model. So longitudinal data and linear models and linear regression. So click this. This is what we are going to use. After clicking this, do the same thing as before. As before, we can do the same thing, and the model we use here is the fixed effects. These are other models. Previously when you don't have any option, you will have this result, but what we need is this. And now let's think about standard error option. We will use clustered robust standard error, and the cluster variable is country. Now in this setup, string variable is okay. So then we chose fixed effects. We chose dependent variable regressors and fixed effects option and robust standard error option with cluster country, right? So cluster country means within country there may be correlation, and across country it is independent. It's uncorrelated. Click OK. Then you have this result. So as you see, fixed effects regression, and there are many unknown, many more results which I did not explain in the slides. And to understand them, it would be nice if you could understand them, but it requires more theoretical derivations and many more lectures. So I will not explain them. Just first observe this. 688. It only uses 688 observations because we use education at the same time. So because you included education, the number of observations you can utilize is reduced to 688 because there are a lot of missing education variable. The missing values are deleted. And number of groups, which means the number of countries. In the end, there are only 97 countries used. Originally, we found that there are more than 200 countries, but more than 100. So in our original data, there were 211 countries, but now it only uses 97. The others, say 114 countries, have some missing variables. So either education is totally missing, so there is no observation that has fully observed triplet of these three variables. So to utilize an observation, you have to observe this at the same time. If one of them is missing, then that observation is deleted. Say by that way, more than 100 countries are deleted. So it's a little bit weird, but at the same time understandable. So like for example, education variable must be very difficult to collect. So the government must be functioning very well to collect this kind of data. But as you may be able to guess, it is not easy. So there are not many countries who especially in the past, like say think about 1960s. Many countries cannot afford to collect such a nice data So that's why many countries are deleted. Anyhow, let's think now, look at the result. It is interesting that this t-statistic is only 0.08. The p-value is 93%, which is very insignificant. Surprising result, I think. Surprisingly, the GDP per capita becomes insignificant after including fixed effects. We are comparing this result to this result. This result is this is the result without using fixed effects. Without fixed effects, the t-stat was 8 point something and coefficient was 0.14, but after including fixed effects, coefficient was 0.14, now 0.00. All gone. So nothing remains here. T-stat is devastated, zero, nearly zero. So that means in the previous regression results, without considering the fixed effects, the coefficient was biased because of the unobserved characteristics that are country specific. So there must be country specific time constant characteristics that are not observed, and these unobserved characteristics are the main reasons why it had a positive coefficient. After controlling for those unobserved characteristics by the fixed effects, it's gone. Still, the education variable has some significance. It's still significant, even though it changed a little, 0.036, 0.041. So increased a little bit. No. Excuse me. 0.048 increased a little bit. So education survives. Education has nothing much to do with the country specific fixed effects. The unobserved characteristics are not much correlated with this. Okay, this is the result when you include country specific fixed effects. Now, I am going to show you how to include year dummy variables. So we would like to include country dummies and year dummies at the same time. They are included at the same time, must be included at the same time. And there is a simple way. By the way, I will show you what is wrong. So you have to include, remember, the idea is to include the dummy variables for the years, the year variable, for the year variable. So maybe you may want to include year in the regression equation, but it is not. This is not what you. This is not correct. Simply by including year in the regression, it includes year as a linear variable. So it means 2000 is like, say, twice larger than 1000. But in our analysis, that's not what we want. We want a year specific value. So let's put it this way. Say if you include it this way, 1960 is included as 1960. 1970 is included as 1970. So as time goes, it always goes up. So 1960, 1970, 1980, 1990. However, economy does not go that way. So usually it may go up, but there are also fluctuations. For example, in 1980s, there was oil shocks. So the economy in 1980s could be lower than the earlier years. So 1960 and 1970 and then 1980 and then 1990. But in near 2000 there was like a financial crisis in East Asia. So it is not kind of linear trend, but it's about fluctuation. So including year in this way, is misleading. So when you have now, if you include year this way, you have to interpret this like so every 1 year, 1 year passed, democracy index increases by 0.004 points every year. That may make sense, that makes some sense, but that is not what we want. We would like to capture the fact that oil shocks happened in 1980s and Asian financial crisis happens in like near 2000, something like that. So then I will show you how to do this. Pretty much the same command, but include I dot year. So this means I dot means identification codes for year. Let's see what happens. When you include this way, year dummy variables are automatically calculated. So year variable is included by using its giving identification number for each of the values. Say 1970, 1975, 1980, up to 2000. So there is some kind of trend which is true, but this is more general and more safe. This is the definition of fixed effects, year fixed effects. In this year, this much shock has happened, but in another year, a different shock has happened. So that's the interpretation. And also another thing you have to realize here is Stata automatically excludes one year. The excluded year must be 1965. It is not shown here, but anyhow, we do not need to interpret this. So this is just to control for the unobserved characteristics. And what I'm telling you here is not like, do you see the difference? Year is not one variable. You have to use t minus 1 number of dummy variables. And it is easy to implement that just by including I dot. So in the slides, there was a different way to use dummy variables. I'm teaching you a much easier way to implement this. So I will also show you the same. So you may apply the same thing to country. I dot country, I dot year. So if you do this, string variable is not accepted. Okay, I didn't know that. So now use I dot code, I dot year. So now let's see what happens. Then every year has its own, every value of the years have its own identification value, identification number, and has its own dummy variable. Also, 211 countries have their own identification number, dummy variables, and they are included. And observe that this result is identical to this result, right? But by the way, the standard error is different because I did not use the standard error option, but this number, these coefficients are identical. If you use the clustered standard error option, the standard error must be the same. So because they are the same, because they are supposed to be the same. The fixed effects model, by definition, is to include country dummy variables. And country dummy variables can be included this way, identical. So this is a very useful command when you want to include a certain variable using its using as dummy variables. Then you may use this command. Okay, I have a little more to explain. I will show you that in the next video. See you later. In the next video, I will show you how to do the to file, a little bit of tricks in to file. See you later. Bye.